Good morning, students. Today we are going to have a class continuing to the alkaloids for PharmD students, for especially Tropane Alkaloids. As I told in the class, they may ask 5-mark question or even 10-mark questions can also be asked. General alkaloids, which we have seen, even including extraction, isolation, all these things you have to go through. And also specifically classification of alkaloids and by chemical classification. And very important for PharmD students, you should know about the pharmacological action and its therapeutic application in the field of health service. So I feel this class is continuation for the previous class of alkaloids, which we have taken in the classroom also. You listen once again, so it will be easy for you to appear in the examination. And you subscribe my channel, and also so that you will get the updates of the new classes which I am uploading. So I welcome the Sri Krishna College of Pharmaceutical Sciences and Research, Parashala Trivandrum, students, PharmD students, and all the PharmD students from other colleges also can attend this, and so that you can appear for in detail about the question. And I would like to inform you so that no student should use pen for drawing the diagram in pharmacognosy. Use pencil. And for chemical structure, it's possible for you to write by pen, but usually for the diagram, botanical diagram, pharmacognostical diagram, morphology, microscopy, TS, everything you have to use pencil, sharp pencil. That's the way to give the respect to the diagrams of a flora. So tropane alkaloids, in general, we should know about the chemistry of the tropane alkaloids. The tropane alkaloids, which have the 8 azo-bicyclo, 2-cyclo-octane nucleus, are commonly found in plants of 3 families. We are going to see today only the Solanaceae family, 2 leaves especially. I have taken this specific leaf because last week you have done the lab by taking the Tropane TS. So the microscopy of the Tropane and as well as belladonna will be helpful for you, and it will be easy for you to compare and to write detailing regarding the microscopy and macroscopy. So Solanaceae family contain tropane alkaloids, not only Solanaceae, Erythrosilanaceae and Convolvulaceae. So this one, the families, especially we are going to see the Solanaceae family, the 2 leaves today discussion. So tropane alkaloids are tropane derivatives. Tropane ring is composed of pyrrolidine and piperidine rings. When you are studying organic chemistry, your teacher might have taught about the heterocyclic ring structure. In that 5-membered ring structure with nitrogen, we will say pyrrole. 6-membered ring structure, we will say it is pyridine. In that, you will say pyrrolidine means when you remove the bonds, when addition of hydrogen or undergo reduction, the pyrrole will give pyrrolidine, and pyridine will give piperidine when it undergoes reduction. When you refer your organic chemistry, you will be clearly. So one is 5-membered ring structure with nitrogen and another is 6-membered ring with nitrogen. This junction the student should understand about the heterocyclic ring structure containing nitrogen, because in the general alkaloids I have discussed about the amines and the alkaloids, what is its relation and how the nitrogen is present in the structure inside the ring and maybe outside the ring also, presence of nitrogen and basicity. Regarding all these things we have discussed in the last class. Revise, listen to the class, and so that it will be easy for you to appear in the examination. So pyrrolidine and piperidine, a 5-membered ring and a 6-membered ring together is found in the tropane alkaloids. Tropane is 3-hydroxytropene. So this is the structure which you can see that the nitrogen present in that inside the ring, and 2 rings are there, which is denoted very clearly. Octane, why we are seeing 8 number of carbon atom is there in the ring, the total ring, and 8 numbers of atoms. In that one is nitrogen, which is attached with CH3. So you can see the tropane, even down I have given that geometrical isomerism of chair shape also, which is shown, and it has stereoisomers of optical isomerism is also there for this structure. Especially in the class I have told, atropine is present in the plant in the form of racemic mixture with hyoscine. Hyoscyamines, not hyoscine, hyoscyamine. So atropine and hyoscyamine are same structure. Only thing is their configuration. Atropine is positive and hyoscyamine is negative, which is, you can see, levo and dextrorotatory due to the presence of chiral carbon atom. This arrow which shows that 5-membered ring structure, this arrow which is showed for 6-membered ring structure. So 5-membered ring structure, if it is pyrrolidine, and 6-membered ring structure piperidine are together is present in an tropane alkaloids. This arrow which I have just denoted, you can see here, the arrow which comes and show the red color, which shows that chiral carbon atom. And we can see in expansion, you can see that this place, the chiral carbon atom, which is having all molecules which is attached to that carbon atom. One is hydrogen, one is benzene, one is CH2OH, another one is C double bond O and with an tropic acid. So tropic acid is one substituent. Benzyl group is one substituent with an alcoholic, and hydrogen is another substituent, and CH2OH is another substituent. So that carbon atom will have, when you come to the calculation which you studied in the stereoisomer, 2 to the power of n, so 2 to the power of 1 means 2 isomers will be there. You have to revise your previous knowledge, basic knowledge which you studied about the chiral compound and the configuration of isomers. If you see, you can see that is in a glucose molecule. You might have studied. I am just giving you a revise of your previous classes you have to revise. Like glucose molecule have 3 carbon atom which they are chiral carbon atom or chiral. You can pronounce it in both the way, chiral or chiral carbon atom. So when you see 2 to the power of 4, then you will get 16 isomers. So in glucose molecule there are 16 isomers which you might have studied. So according to the chiral carbon atom present in the compound gives the optical isomerism. Optical isomerism means, you may be knowing very clearly, when a plain polarized light falls on an organic molecule, it has its own rotation. When there is a carbon atom, chiral carbon atom with different atoms which is attached in a carbon atom, will have its own rotation, plane of rotation. So that's why we can see sometimes writing the structure in the chemistry above the plane, below the plane, like that we used to write. So you have to revise your knowledge. So this I am imposing in you because these all things will help you to write in the examination. Points will not forget from your mind. So you see this structure. This structure writing is very important in pharmacognosy. When you write pharmacognosy and phytopharmaceuticals, it is must for you to write a botanical source clearly and a chemical constituent with structure and drawings of any TS with pencil, macroscopy, microscopy, drawing of a floral diagram or a flora diagram, it's needed to be drawn by a pencil. And you see here, this chemically, hyoscyamin, as just now I told, hyoscyamin and atropine are same structure. They are optical isomers. So chemically, atropine consists of a racemic mixture of positive and negative hyoscyamin, which is having same chemical structure, of which negative isomer is more potent. Hyoscyamin is more potent than the atropine. However, the racemic mixture, atropine is used because negative isomer racemize in solution. So in solution it can be used. So we will see that what is its application. See here, only the difference, the arrow which I have brought now to show you, scopolamine is having a difference. Scopolamine is having a difference. Scopolamine is having an lactone ring, 3-membered lactone ring, which is just attached in the tropane. So scopolamine is also one constituent which is present in belladonna. So that's also, you should know that chemical structure, very easy chemical structure. Once you write and see, it is easy. It's an ester, you can see, they are tropane COO, then it is attached with the CH, CH2OH and a benzene. So you can see RCOO, R means ester, which is formed from an alcohol and an acid. So ester, it is an ester, atropine, hyoscyamin, scopolamine, all of them are esters. So the ester linkage which I want to show by arrow, all the red arrows which shows the ester linkage are COOR, tropane, COO, then comes benzyl or propyl alcohol, benzene with attached with an CH2, CH2OH, CH2OH, that is ethyl. That means benzyl means only one CH2 should be there. There is two CH2OH is there, like which you have seen in many other structures. So Atropa belladonna belongs to a family Solanaceae. Atropa belladonna, commonly known as belladonna or deadly nightshade. You should know about the synonym of Atropa belladonna, deadly nightshade. Sometimes in university question they may ask, write about deadly nightshade, so that the student should not confuse. Deadly nightshade is Atropa belladonna. Is a perennial herbaceous plant in the nightshade family Solanaceae. Definition, if you want to say botanical source, definition, pharmacognosy definition, that means belladonna herb consists of dried leaves and flower tops of Atropa belladonna containing at least 0.3% alkaloid hyoscyamin. So it contains 0.3% alkaloid hyoscyamin. Dried leaf, belladonna, flowering tops, Atropa belladonna. So you can see the shoot system, the shoot system is used for the medicinal purpose. Traditionally, in British pharmacopoeia, drugs the drug has consist of, that means the belladonna consists of all the aerial part of belladonna herb, but under European requirements, here is a limit of 3%. In European standards, whenever you are exporting or importing towards Europe, they have a specification 3% of stem with a diameter of minimum 5 mm. USP, United States of Pharmacopoeia, also allows Atropa acuminata in the belladonna leaf monograph. So this species also allowed, which contain strong alkaloid. This is the flower tops and the berry, also very beautiful berry. This picture is from Egyptian tomb and Egyptians were used, this was poisoning also. The species of epithet comes from the Italian word belladonna, which is called a beautiful woman, and a reference plant used by the vegetarian ladies for beautifying the coat, who dilate their pupils. When you are using this juice, when you use this purple berry and as well as leaf juice, it dilates people because it is an anticholinergic drug. Anticholinergic drug or parasympatholytic drug. Atropine is present, which can dilate the pupil. Mydriasis will take place with the tincture of belladonna eye drops, which makes beautiful of the lady. You can see that this berry also, very beautiful berry, the arrow which came from the top, which will show you the berry, and they used to put in the drops in the eye and makes more beautiful, attractive. And it has been used for poisoning also in those days. As with many poisonous plants, there are many reasons for their use, both good medicinal and bad weapon as a poison also. So you can see belladonna leaves with flowers like this. Morphological character. The drug consists of leaf and their small stems. Rarely stem exceeds 5 mm diameter. Together with flowers and fruits, the aerial part is used. Color, leaf greenish or brownish green. Flowers purplish to yellowish brown. Fruits greenish to brownish in color. Odor, like organoleptic character. You should know about color, taste, odor, texture, morphological character includes all the organoleptic characters. Odor slightly or slight, very slight odor, not an aroma or anything, slight odor. And characteristic, that means its own characteristic. Taste, bitter and acrid. Size, leaves are 5 to 25 centimeter, 2.5 to 12 centimeter. Flower corolla, you know corolla, calyx, corolla, the flower corolla, 2.5 centimeter long and 1.5 centimeter wide. Fruits about 10 centimeter in diameter. Shape of the leaves is ovate, lanceolate to broadly ovate and brittle. Flowers campanulate, that means bell-shaped. Flowers are bell-shaped. Campanulate or campanulate. 5 small reflexed lobes of corolla. Fruits, berries, beautiful berries, subglobular in shape with numerous flat seeds inside the fruits. Now we are coming to the microscopy of Atropa belladonna. Here you can see cuticle, striated cuticle, palisade cells, elongated cells. See the picture so that you can remember what you did in the lab. You have to compare the theory and as well as the lab when you study, which observe in the microscope. That's why I used to make the student to ask which part can you identify in the microscope. Focusing microscope, identifying the parts is very important for you before diagram. So palisade cells are below the epidermis or striated cuticle next to epidermis. Then comes palisade cells, elongated cells. Pre-medullary phloem can be seen and xylem, which we have seen in the Datura stromatonium, same structure. Phloem in between, phloem, xylem together, you can say that is in the midrib region which we call as vascular bundle in most of the time. Even in the mesophyll area also sometimes vascular strands also can be seen. Idioplast cells can be seen in the cortex area of the midrib region. Unicerate covering trichomes and glandular trichomes are also in some places of the both upper epidermis and lower epidermis. Stomatas can be seen, and clubbed shaped glandular trichomes as shown in the picture, and we can see colonchima cells both in the midrib region of lower epidermis, near to the lower epidermis and upper epidermis, very promptly round shape. So this is one thing which you should remember. When you are writing about leaf, the student should have to be able to know that there will be lamina, the leaf area, and the midrib region, the main vein, round shape, convex, and there will be concave also in some leaf, but here it is convex both the sides. So you can see that transverse section of the leaf of Atropa belladonna has a bifacial structure. Student have to write very clearly. The epidermis cell have wavy wall and a straighted cuticle. The thick, dark and green color, thick cuticle can be seen. And when you see anisocytic type, and some of them are anamocytic type of stomata are present. So both anisocytic means prominent 3 cells will be there. Anamocytic, additional 1 more cell, which you have studied in your cellular structure first chapter. You can see that the picture which I have shown here, that is these two, the arrow which shows this anisocytic, you can see very prompt 3 cells surrounded the stomata. That is the palisade cells which surrounded are epidermis cells, palisade cells which is surrounded the stomata, 3 cells. Anisocytic. Anamocytic also 3 cells, but additionally 1 more cell will be there. Both are similar. So these type of stomatas are present both in the upper epidermis and the lower epidermis of the structure. A certain of the cells of the spongy mesophyll area, the lamina area below the palisade cells, spongy mesophyll are filled with microsphenoid crystals, sandy crystals of calcium oxalate. So calcium oxalate crystals are present in the where? In the lamina. Lamina means the leaf will be having side to projected, that is lamina area, which we can say spongy mesophyll area. The crystals will be, even it may be present in the middle rib also, but more will be found in microsphenoid. That means there is rhomboid crystals, needle-shaped crystals, prismatic crystals, microsphenoid crystals are also seen. Very clearly sand-type crystals in calcium oxalate we can say, observe in your 45x microscopy. When you focus, you can find out the shining crystals of calcium oxalate. The midrib is convex. It's not concave, it's convex. You can see it's like an lifted, a bend. You can see that like a bell shape both the side. So the midrib is convex above the show and above and shows usually bicollateral vascular bundles which you can see. Xylem and phloem are vascular bundle which is present in the middle. A zone of colonchima is present in epidermis near the midrib, lower and the upper colonchima cells. Atropa belladonna constituents. Now we are talking about the constituents. Chemical constituents which we have discussed in the beginning itself. The drug from Atropa belladonna contains 0.3 to 0.6% alkaloids. The chief alkaloid is hyoscyamin. Again, the student should remember hyoscyamin and atropine are similar structure. They are isomers, and hyoscyamin is levorotatory, negative, left side rotating, negative rotation, levorotatory, which is highly powerful. But usually they are present in racemic mixture in nature. Hyoscyamin, small quantities of volatile bases such as pyridine and N-methyl pyrrolidine are present. Because you know that a 6-membered ring and a 5-membered ring is present in tropane alkaloids, and it is present in atropine also and hyoscyamin also. So they should be formed always synthetic molecules. The structures which is formed from the precursors are smaller structures or smaller base starting materials. It should have pyridine 5-member ring structure, pyridine 6-member ring structure, and N-methyl pyrrolidine 5-member ring structure, which is joined together, and you are getting the tropane alkaloid. The leaf also contain fluorescent substance 4-methyl esculitin is another constituent which is present usually in the leaf, and calcium oxalate crystals, calcium oxalate is also present. They yield about 14% of ash and not more than 4% acid insoluble ash. This is about physical parameters which you might have studied in your evaluation of crude drugs chapter. You might have come across what is ash value, what is moisture content, what is refractive index, what is foam index. This all comes in the physical evaluation of crude drugs. So just we gave the data for the ash value. Root contains 0.6%, stem contains 0.05%, leaf contains 0.4%, unripe and ripe berries 0.19 to 0.2%, and seeds contain 0.33% of alkaloids. The main alkaloids are levorotatory hyoscyamin and its racemic mixture of dextrorotatory atropine. The drug contains belladonna and hyoscine also. You should know that hyoscyamin is different, that is hyoscyamin and atropine are similar, but hyoscine is different. Hyoscine is the other name for scopolamine. That is what you can say, scopolamine can be called as hyoscine. Scopolamine, I have seen, students should not get doubt. You see this structure very clearly, the atropine and hyoscyamin are similar structure. Only hyoscyamin is a levorotatory or negative structure of negative rotative configuration or the isomer, and atropine is a dextrorotatory. More powerful is hyoscyamin. Usually they are present in racemic mixture. Both will be present. Understand? And scopolamine is also present. Only thing is there is an additional lactone ring of O. Atropa belladonna, allied drug, Indian belladonna, Atropa acuminata, even United States Pharmacopoeia also accept this drug. Yellow brown flowers, not purple flowers, brown green leaves, and Atropa baetica, that is yellow flowers and black berries. Endangered species like this blackberries you can see, and this berry is also seen in Indian belladonna in some species. Like adulterants can be given by means of phytolacta decandra and Ailanthus glandulosa. They are adulterants which can be adulterated for this belladonna, Atropa belladonna. And uses, when we talk about, this is very important part. I have given 2-3 slides for this for PharmD students especially. You should know about application. What is its therapeutic action? What is its therapeutic application by its pharmacological action as a natural drug? So belladonna leaves are mainly used for internal preparation which uses a sedative and to check secretions. Because it is an anticholinergic drug, it has more power to reduce the secretions. So the root preparation mainly used externally as a parasympatholytic, opposite to acetylcholine. The neurotransmitter of parasympathetic nervous system, you know that very well, cholinergic drugs, which acts what all the activity done by acetylcholine. This is opposite, parasympatholytic drug, whose anticholinergic properties are used to reduce the secretions such as sweat, saliva, gastric juice, and reduces the spasm in intestinal gripping due to strong purgative action. We have discussed about what is purgative action. So, the PharmD students, it is very important when you come to the part of pharmacological use and therapeutic application. It is necessary for the PharmD students to know more reference and utilize, read, and to make your knowledge more and more update, not only about the natural products and what is its application, how it can be used, and what is its therapeutic application. So these all makes you more competitive words. For example, when you update and make powerful, then only you will get the strong identity and recognition in the health sector. So it is also used as an antidote in opium and chloral hydrate poisoning. So when the class, I asked some question like that, what is antidote, and student immediately told about acetylcysteine, which is used, when I was asking, so the student are knowing antidote, acetylcysteine is used for an antidote for a paracetamol poisoning. Then I was asking about general poisoning, what you can use a universal antidote. Then we were discussing about the activated charcoal. So antidotes will be used for poisoning, maybe overdose, intentionally, non-intentionally, it happens. So we have to need an antidote to save the person from the toxicity. So in atropa belladonna, pharmacological activity, when we talk about little more, atropine and hyoscyamin, which are present in racemic mixture, have a same activity because they are, only the potency is more for hyoscyamin. Atropine acts by competitive, reversible inhibition of acetylcholine binding on its receptor, as because it is an parasympatholytic or anticholinergic action against acetylcholine. So you see, it's a competitive and reversible inhibition of acetylcholine binding sites of the receptor. In the heart, after temporary bradycardia, atropine increases the heart rate. So it can help in certain temporary bradycardia. We'll see in congestive heart failure, cardiac arrest. These all things will come with bradycardia. There you can even give some support by this medicine. Atropine increases the heart rate by suppressing vagal inhibition. In the blood vessels, the effect on blood pressure is not very much marked. Belladonna, fruit, root, leaf are toxic. The ingestion of the plant induces turn red the mouth and mucosa membrane or mucosal membrane turn dry because of reduction of the salivary secretion and intense thirst, and the muscular weakness develops. The heart rate increases substantially. You know why? By means of suppressing the vagal inhibition, and it causes mydriasis, hyperthermia, also always observed by this drug. Hallucination also, for some extent, flying feeling, and delirium, not like alcohol or morphine, but hallucination and delirium. A psychotic feeling will also happen, action, followed, accompanied by agitation, sometimes convulsion also. You might have studied anticonvulsive drugs in your pharmacology recently, or your teacher might have told, because you are going along a parallel subject in which you are studying about anticonvulsant drugs like phenytoin, sodium valproate, and phenobarbital or barbiturates. This all comes in the anticonvulsant drug. So this will cause agitation, convulsion, sleeplessness, or even coma if it is overdose is the next stage. Recovery takes times 1 to 3 days. The patient must be monitored and may be treated with charcoal or sedatives. So you should know the antidotes, and also you should know about the treatment for toxic things. Now we are coming to the Datura herb, which you have done in the lab, which is commonly available in our place, in the roadside, white flowers with thorny fruits, which is a picture which is shown in the slide. Datura herb. So biological source, Datura herb consists of dried leaves of flowering tops of Datura metal. Len is the scientist name, and Datura metal variety of Fastuosa belonging to the family Solanaceae. So geographical source, it is found in India, England, and other tropical and subtropical countries. Characteristic, Datura metal is also a Indian plant and resembles Datura fastuosa. It differs in that the leaves are heart-shaped, almost entire and downy, and the flowers always white in color. Microscopy, which you have done in the lab, colon-chema cells, which I have shown in this picture, it is not very correct. Palisade cells, this is a schematic diagram just to show, it will be round. Colon-chema cell can be seen in the below epidermis and lower epidermis, it is possible to see. Trichomes can be seen also in the lower epidermis and upper epidermis. And vascular bundles, which I have shown in the picture, and the mesophyll area can be seen in the lamina. Transverse sections show a bifacial structure. The following structure were observed in a lamina and in the midrib region. In the lamina, it has the upper epidermis, which is single layer, rectangular cell covered with cuticle, striated cuticle, which you have seen in the belladonna. Both covering and glandular trichomes are present. And the covering trichomes, they are hairs, are uniserrate, multicellular, warty, and blend apex can be seen in the unicellular trichomes. This is the picture, real picture, which you have to draw very clearly. It takes not even 5 or 10 minutes if you draw properly with pencil. You can see that the glandular trichomes have one stalk containing on one cell and of one cell or multicellular heads. The mesophyll area, that is in the lamina, mesophyll area, spongy parenchyma, and the palisadal elongated cells in it, it's seen very clearly. And palisade cells are readily elongated, single layered, compactly arranged, very compactly arranged. You can see the arrangements in the picture. Spongy parenchyma are several layers which you can see, loosely arranged, consist of microsplenoid crystals of vascular strands, that is the dark strands can also be seen, pinkish color. If you use fluoroglucinol for straining in the lab, it is possible for you to see because it contains lignin. So when you see this structure, in the midrib region, midrib strips, the collenchyma appears below and upper, above the lower epidermis, followed by cortical parenchymatous cells containing calcium oxalate crystals. Lower epidermis is similar to that of upper one. More number of trichomes and stomata in the upper epidermis you can see when compared to. See, that is the arrow which is showing glandular trichomes. This is unicellular trichomes, and this is about the upper epidermis and lower epidermis, and that is the collenchyma which is present in the upper epidermis. This is collenchyma which is present in the lower epidermis, and this is the calcium oxalate crystals, splenoid crystals, saprophytes of crystals which is present. Stomata, lower epidermis also present, and upper epidermis more stomatas can be seen. And this is also, even it can be seen in the midrib region of cortex parenchymatous cells. You can see microsplenoid calcium oxalate crystals. This is about the phloem cells or phloem cells, that is the vascular bundle phloem cells in between the xylem. This is xylem cells which I have seen. So you can see the pictures, arrows which I have shown just to make you to understand the diagram very clearly. Very important. And chemical constant datura herb contains up to 0.5% of total alkaloids, among which hyoscyamin, not hyoscyamin here, hyoscine. As I told, hyoscine means scopolamine. Hyoscyamin and atropine are similar. Hyoscine and scopolamine are similar. Is the main alkaloid, which is L-hyoscyamin and scopolamine and tropane. Atropine are present very less quantity in datura, but they are present more quantity in belladonna. So this is scopolamine. Chemical test is very important. We have studied the general chemical test like Mayer's reagent, drag and draft reagent, Weger's reagent, picric acid, Hager's reagent. These all of them give precipitate, white precipitate, orange precipitate, and yellow precipitate, and you can see a green precipitate. These all things will be obtained by that iodides in alkaloid, general alkaloids. But when you see the tropane alkaloids, this one is very important to remember. The students have to make it. The tropane alkaloids is treated with fuming nitric acid, followed by evaporation to dryness, and addition of methanolic potassium hydroxide solution to an acetone solution of nitrate residue. Violet coloration takes place due to tropane derivative. So very easy to say that violet coloration will form. Just I have shown a china dish. The student can easily remember if I say how to do that. Let's take a china dish. Keep the drug which you are interested to check the tropane alkaloids and add concentrated nitric acid and dry for dryness in the china dish. Once it is getting dried, the residue, which is called nitrate residue, according to the procedure, you add little acetone, make it into acetone solution. Understand? And then add alcoholic potassium hydroxide, 2-3 drops. You will get this color which is shown there. Violet coloration will take place. That shows the tropane derivatives are present. On addition, silver nitrate, another test, very simple. Silver nitrate solution, if you add a compound containing like tropane alkaloids like hyoscine or hydrobromide is present, yellowish white precipitate is formed. And this precipitate, which is insoluble in nitric acid, a special character, which is soluble in but ammonia, dilute ammonia, ammonium hydroxide, when you add, it will be soluble. So that is a good identification. This structure is shown just for you to remember again. Uses, many pharmacological uses which you have seen in belladonna is applicable here also. In Ayurveda, the black datura is considered more efficacious or more toxic. Datura metal is used in manufacturing of hyoscine and scopolamine. Datura metal is used to the extract and to prepare hyoscine and or scopolamine. It exhibits parasympatholytic, anticholinergic and CNS depressant effect. The drug used for cerebral excitement, asthma and cough. Other uses you can refer the belladonna also. Thank you very much for listening to the class. Listen, read, and that will helpful for you to go for good in your ready for your final exam or your university exam. It is very important for the students to listen and to read